All right. We are in 6.3. So I, again, forgot to label your papers. Label it 6.3. If you're watching this video way in the future, maybe I labeled it for you. You don't know. All right. So we were talking about trigonometry, and we've done trigonometry before. This is not we, but you have done trigonometry before in Math 2 for sure. So we're going to do a little review over it first, and then you'll do a little bit of practice. And then tomorrow we're going to jump into unit circle, or the next time we'll jump into unit circle. All right, so sine, the saying that can help you remember is this. So, toa. So opposite means the O. A is your adjacent. And H is your hypotenuse. I'm going to run out of room. So in sine, we are referring to so, and I totally spelled that wrong. So, because it's SOH, because it is the opposite. Where is my highlighter? The opposite over the hypotenuse. So we have the sine of A, which is referring to the angle. So referring to angle A, the sine would be, I'm going to use green, the opposite, because that is the opposite side from that angle, over the hypotenuse. And the hypotenuse is always across from the right angle. So if I wanted to write that ratio, it would be A over C. And then for B, let's come back over here and we'll look at angle B. And again, for this, it is the opposite because it's the side that's across from it over the hypotenuse, which was already labeled. Again, that is the same always. It's always across from the right angle. So here I would have B over C. Cosine then, or C-A-H, is the adjacent. Oops, I thought that was a highlighter. Over the hypotenuse. So adjacent would be right beside. It's the side right next to the angle. So if I wanted the cosine of A, the side right next to that angle is right here. So this would be the adjacent side for A. So it would be B over C. Cosine of B, the side right next to it, right next to the angle, is A, so it would be A over C. Then we have tangent, so that would be our TOA, because it is the opposite over the adjacent. TO, opposite, A, adjacent. So it is the opposite over the adjacent. So if we're looking at the tangent of A, we're going to look at our angle for A, which is here. The opposite is our A, and then the adjacent is B. So it's going to be A over B. And then if we want the tangent of B, we are going to have B, tangent of B, angle B is here. So the opposite is B over the adjacent, which is A. So B over A. I'm going to zoom out just for a second, just in case some of you missed that. If needed, you can pause here so that way you can write anything down that you might have missed. So as we just talked about, we've got SOHCAHTOA, which is the opposite over the hypotenuse, or the adjacent over the hypotenuse, or the opposite over the adjacent. So some examples, we're going to go through at least one of these. You've got your sine of A, which means that we are focusing on the angle that has A. So the sine A, let's do this. Sine is opposite over the hypotenuse, so the opposite is H. And the hypotenuse is always across from the right angle. So this one over here will always be the hypotenuse. So we've got, for that first one, 5 over 13. The next one is asking us about the cosine of A. So the adjacent side to A is going to be the 12, and cosine is adjacent over hypotenuse, so it's going to be the 12 over the 13. And then tangent is opposite over adjacent, so the opposite side is 5, and the adjacent side is 12. The next one here, it asks us for sine, cosine, and tangent if we were using angle C. So using angle C, the opposite side is 12. The adjacent side is 5. And then the hypotenuse is always the hypotenuse. So we're going to have the sine, which is opposite over hypotenuse. The opposite is 12. The hypotenuse is 13. Cosine is the adjacent, which is 5 over the hypotenuse of 13. And then tangent is the opposite, which we said is 12, over the adjacent, which is 5. If you need to pause it so you can grab that, that's fine. Otherwise, try the next one on your own. So before you, because you might be looking at this saying, oh no, there's no value for my hypotenuse. We're just going to use a little y just to save some time. We're not going to worry about solving for that side. We can, but we're not going to. So just put a y there and use a variable. Now pause. All right. Go ahead and check your answers. See if you got it right. Hopefully you did. And then you can go ahead and flip to the next page. If you need to pause so that you can check it, totally fine. All right, a trigonomic function is a function whose rules are defined by a trigonomic ratio, and the ratio is comparing the lengths between two sides. You will see the Greek letter theta to represent those sides, and we've talked about that Greek letter before, just letting you know it's going to come up again. So again, your sine is the opposite over the hypotenuse. You're just going to keep hearing me say it because I want you to remember what it is. You're going to have the cosine, which is the adjacent over the hypotenuse, and then the tangent, which is the opposite over the adjacent. All right, so We are also going to have the reciprocal functions, and the reciprocal just means the fraction flipped. So you can write it as 1 over sine, but sine we know is opposite over hypotenuse, which would be a fraction and a fraction, which is really ugly. So you're just going to take sine and you're going to flip it. So we're going to have the cosecant, which is going to be the hypotenuse over the opposite. So you're just taking the fraction first line and flipping it upside down. Then you're going to have the hypotenuse over the adjacent for the secant, which is the reciprocal of cosine. You're just taking cosine and flipping it upside down. And then same thing for tangent. You're going to do the adjacent over the hypotenuse. All right. So again, let's do a little geometry lesson. If you don't remember, you can solve for the hypotenuse by doing a squared plus b squared equals c squared. The A and B are the sides of the triangle. C is the hypotenuse. So these are the sides. C is the hypotenuse. We don't know the hypotenuse, but we do know the two sides. We know that we've got 30, and then we can plug in 16. Oops, squared. And that gives us 1,156 equals c squared. But we want c. We don't want c squared. We just want the side, not the side squared. So we're going to take the square root of that. And we get 34. You won't necessarily have to know how to do that, but it's good review. You might need to know how to do it for the check-in or the EOC. All right, so sine is opposite over hypotenuse, and we're using this angle here. So this is the opposite. This is the hypotenuse. Hypotenuse is always across from the right angle. So I've got 16 over 34. So then for cosecant, which is the reciprocal, we just flip that fraction upside down. We're going to have 34 over 16. Cosine is the adjacent over the hypotenuse. So our adjacent is 30 over the hypotenuse, which is 34. And again, secant is just the reciprocal. Flip it upside down. So 34 over 30. Tangent is the adjacent or the opposite over the adjacent, which would be 16 over 30. And then for cotangent, you just flip it upside down. 30 over 16. And that's all that those ones are. Let's see here. Do we want to do I want to do this all with you, but I'm going to do that part with you in person. So we are going to stop there. You can go ahead and go open your laptops, get onto Delta Math, and you have an assignment.